I know the red is a little faint, so hopefully you can kind of see it, hopefully. I'm going to go over two examples of integration by parts to show you how to choose u, how to choose v, and just approach these kind of integrals. If you see this first one, right, let's go over this first one. X sine 2x squared dx. That's not, that seems like, that seems kind of easy, right? You just do your u substitution. You could set u equal to 2x squared, and then what you could do, so u is equal to x squared, and then I could say du is equal to 4x dx. I can essentially, then I have x dx. I can multiply both sides by 1/4, and I can substitute in 1/4 du. That's not too bad. You can't do u substitution when your this 2x squared becomes just 2x. That's when you can't use u substitution, because you're going to see that, like, hey, u is going to equal 2x, du is equal to 2 dx. There's no way you can get, because you have an x now, x in there, x dx, and it's like, well, I don't know how to deal with x's and u's, and it's just going to get messy. So what you're gonna have to do? You're gonna have to do integration by parts. So I'm gonna show you how to choose u and v accordingly. You want u, so the general rule of thumb is you want to choose u so that the derivative of u is better. So it's like makes it easier, makes it less, reduces the problem a little bit. And then v, you want to choose v so that at least the integral is possible. So u, I wouldn't choose sine 2x, right? If I choose u to be sine 2x, the derivative is 2 cosine 2x, right? Times dx when you do your du. That doesn't reduce the problem. One might even argue it makes the problem a little bit more, or not problem, but makes the scenario a little bit more worse, right? Because now you have that 2 in there. The derivative doesn't make it better. The derivative of x sure does make it better, because then I could just say du is equal to x, or 1 times dx. And then I know my v, it's not just sine 2x, it's the rest of the problems. If I take away my u, my x, I get integral sine 2x dx. And I'll use my v like this. So, and then if you take the integral of sine 2x dx, you could do your u substitution, set u equal to 2, or not u, you would have to set like w or some other variable to 2x. But if you just kind of think about it, I know that the derivative of, so I know if I were to take negative cosine 2x, I would get 2 times sine 2x. So then I would just take the negative 2 and multiply by 1/2. I would get negative 1/2 cosine 2x, right? If you just think about when you're taking the derivative, you're doing your chain rule, so that 2 multiplied by 1/2, it'll just make it sine 2x. If that didn't make sense to you, just do your u sub for this integral. And then the reason I'm doing this is so that my dv, right, as I just kind of explained, my dv ends up being sine 2x with the chain rule and stuff. And then that's nice, because then x is our u, and then this sine 2x dx becomes our dv. So I know integral of u dv is equal to u v minus integral of v du. Integral of u dv is going to be our x times sine 2x dx. And yeah, then it just becomes kind of straightforward, right? Once you've chosen your u's and v's, it becomes kind of easy. So I get u times v, so I get x times negative 1/2 cosine 2x minus integral of, now we have our v du. So v times du, which is, I don't know why I wrote v. V is negative 1, or sorry, wait. Did I mess up? u dv. Did I mess up? It's v du. I don't think I messed up. I think I'm doing this right. Negative 1/2. Yeah, I did do this right. I don't know why because I thought that, this would make the problem harder, but it really won't, because then I just have du be 1 times dx, right? So, and this is my v du, right? So v du. Now think about it for a second. It's good that I chose u, right, as my x and v as the rest, right? If my u was, let's say, here, I'll do this maybe in a different color. If I set my u to sine, so maybe I don't know, I'll just do this. If u is equal to sine 2x, then my v would be the integral of 1x dx, which is just 1/2 x squared. If that was my, right, if that was my v, I would have v over here. So my v, so really what I would get for this portion instead would be integral of v du, which would be 1/2 x squared, times sine 2x, or I guess du, which would be 2 cosine 2x. If I chose my u and v wrong, this just becomes really stinking hard, because the problem kind of got worse. Instead of x sine 2x, I'm dealing with a higher power, x squared 2 cosine 2x. So if you choose your u and v wrong, you're gonna realize kind of through the process, like, wow, that integral became nastier. So that's when you know to go back and choose your u's and v's accordingly. So it's not like, it's going to be pretty clear if you choose your u's and v's wrong. You might as well just get your u's and v's right the first time, save yourself some time, and then this integral doesn't become too bad, because then I get, it's going to equal negative 1/2 x times cosine 2x minus the integral, so this 1, it's just 1 times dx. So I get integral of 1/2 cosine 2x dx. This is really just, is it just sine 2x? I think it's just sine 2x, right? Minus sine 2x plus c. Let me just double check, because I think, yeah, if you wait, it's not. It's definitely not. I don't know why I said it was sine 2x. It would be wait, would it be sine 2x? What am I doing? Well, I feel like I'm messing up. I feel like I'm screwing up here. If you do your u sub, I think it's 1/4. Is it? I don't know what's going on today. I think it'd be 1/4 sine 2x. Or I guess it would be negative 1/4 sine 2x plus c. Let me just, yeah, because then if you do your chain rule, that's what you get. So then this negative becomes a positive. Hopefully that's right. Now I'm like doubting myself. I don't even know if I got that right. I think that's right though. I think that's right. Because then if you took your, this is probably right. I'm just gonna go with this. Correct me if I'm wrong. Yeah, I should be more confident in my answer. Should I just do u? I'll do u sub to be safe. So if my omega, or my w whatever, is 2x, then dw is equal to 2 dx. I have a 1/2, so to get a 1/2, it would be times 1/4. Yeah, I think I did that right. So yeah, that's how you would go about doing u sub, or not u sub, sorry, integration by parts for that problem. All right, let's do this next one. Oh yikes! Integral of tan inverse of x dx. We don't know any, like, I don't know anything that when you take the derivative of it, you get tan inverse of x. I know the derivative of tan inverse of x is 1 over x squared plus 1, but I don't know what we'll get arriving to that. But I also don't see any, like, there's no u sub you can do. I don't see any like product of two functions though. This is where you kind of have to like use kind of some problem solving skills and be like, well, this is really the same as the integral of 1 times tan inverse of x dx. So to go about doing that, you know, it's pretty cut and clear what is going to be your u, what's going to be your v. Remember, you choose v so that the integral is possible. If I choose this to be v, tan inverse of x, well, that's not helpful because then I'm going to have to eventually do my, you know, v du, take the integral of v. I don't know what the integral of tan inverse of x is. That's what this whole problem is asking me. So I'm going to choose that to be my u. So u, and that's one of those things where it's like, well, you know, wouldn't the derivative of u be better? Or derivative of 1 be better? Why can't that be our u? Well, it's because tan inverse of x for sure can't be our v. So u is equal to tan inverse of x, and I know du is equal to 1 over x squared plus 1 dx. Okay, my v is going to be integral of 1 dx. So my v is equal to x, and then I know my dv is going to end up being that 1 times dx. So boom, I successfully got this into where, well, this is my u, and then the 1 times dx is my dv. So I can do integration by parts. So I'm going to set it equal to u times v minus integral of v du. So u times v is that's just x times tan inverse of x, or tan inverse of x times x, whatever. make the order consistent, but I'll just write it like this because it looks nicer. Integral of v du, so it would be x. Now du becomes times 1 over x squared plus 1 dx. Okay, so this is not one that's super trivial. Like this one you can kind of do in your head, but this you kind of have to actually go, wait, that's a whole integral in and of itself. Minus integral of x over x squared plus 1 dx. The nice thing you can do here is now you can do like traditional u substitution, right? So I'm going to set, for this integral, I'm going to set w to be x squared plus 1. I'm going to set dw to 2x dx, or 1/2 dw is equal to x dx, right? And that's nice because then I have x dx over here, over x squared plus 1. So I really get x, so the whole thing is equal to x tan inverse of x minus integral of, what is it? It would be x dx over x, so 1/2 dw over w. So this would be equal to x times tan inverse of x minus, I'm going to pull out that 1/2 integral of 1/2 integral dw over w. Hopefully that you should for sure kind of know is natural log. So I get x tan inverse of x minus 1/2 ln absolute value of w, and then, or plus c. And I know my w is just x squared plus 1. So I'm going to move this over here. So it's equal to x tan inverse of x minus 1/2 ln of x squared plus 1 plus c. So there you go. That's, if you were to take the derivative of this, you would get tan inverse of x. I dropped the absolute value sign, by the way, because x squared plus 1 has always a positive range. Like if you were to graph x squared plus 1, it's never going to be negative, so you don't need the absolute value. If you do have them in there, that's totally cool too. So yeah, that's how you use integration by parts. Hopefully I did this right. Let me just, actually I'll quickly double check this one. So if I do my product rule here, I get x cosine 2x, or I should say negative 1/2 cosine 2x plus x. I'll do that later. I'll verify this is right, and then I'll I don't know, I'll let you know in the comments or something. But yeah, thank you for watching. Hopefully this kind of clears up how to choose your U's and V's. Thank you for watching. Have a splendid rest of your weekend.